Hi class, today we're going to be looking at making compounds and kind of understanding how to make a compound. So these are the 6 questions we have for today. The first 4 questions are kind of a review of what we've done in the past lessons. So they're not really new information. And then questions 5 and 6 are really looking at the new information. So number 1, what is the oxidation number for magnesium? Number 2, what does a positive oxidation charge mean? Number 3, what does a negative oxidation charge mean? Number 4, what is the oxidation number for chlorine? Number 5, make a compound with magnesium and chlorine. And number 6, what exceptions are there when making a compound with a polyatomic ion? Now, a couple of these questions you would find just from the periodic table. For instance, the oxidation number for magnesium and the oxidation number for chlorine are found on the periodic table. If we were to look at these 2 questions, they deal with that term ion based on whether they are taking electrons or giving them away. And those are all reviews from past sections. All right, so today we're going to be looking at making compounds. The naming we'll get to on the next section of notes, but we're going to look at making the formulas. So a compound formula, you actually wrote this in a couple days ago. It's a chemical symbol and the number of atoms that are used. As an example, we have H2O, water, which has 2 hydrogens. Oh, sorry about that. Let me go back. It has 2 hydrogens for every 1 oxygen. So this 2 relates to the element that comes before it, and there's only 1 oxygen. We don't have to write a 1 here because we assume that there's 1 because we have the element symbol written. So 2 hydrogen atoms for every 1 oxygen atom. So we're going to go through the steps for making a compound. And if you heard these in class, we said that I have 6 steps, but really you could narrow these down to 3 steps and almost 2 steps, and you'll get good enough that it really just kind of, you do this all at once without having to separate it out. But if you follow these steps, you'll definitely be able to do it. So step 1 is find the chemical symbol. This is on the periodic table. Step 2 is find the oxidation number for that element. You wrote these on the periodic table. If you don't have your periodic table, the oxidation number is based on the number of electrons the element will give or take. And that is based on the number of valence electrons. So the goal is to get to 8 outer electrons. As a reminder, if it has 1, 2, 3, or 4 outer electrons, it will be a positive ion, meaning that it gives away that number of electrons. If it has an outer shell with 5, 6, or 7 outer electrons, it will take on the number of electrons to get to 8. So those will be negative ions. Number 3, we're going to write the chemical symbol with the oxidation number as a superscript. As an example, that is down here, sodium +1, chlorine -1. And those you can get from the periodic table. So Na +1, Cl -1. Step 4 is when it's called the crisscross method, and what we're going to do is give the number to the other element. And at that same time, we're going to get rid of the plus and minus, and that's step 5. So we're going to get rid of that plus and minus sign. So right here, we have a formula, Na1, Cl1. The thing is, when we get to step 6, we don't have to write 1s. We assume that the 1 is there. So you can just write NaCl. This is table salt. So again, our steps are find the symbol, find the oxidation number. You write those next to the symbol as superscripts with that number, that plus and that minus. You trade the numbers and get rid of the plus minus, and then you have your compound. So we're going to practice a few. This would be a great time to pause, look them up on your periodic table, try them, and then come back and hit play and see how they're done. So check your answers. So the first one here, calcium and nitrogen. Calcium is a +2, get that from the periodic table. Nitrogen, and really what we could do here is just put N -3. And then what we're going to do is trade those numbers. So notice we take the 3, we give it to calcium. We take the 2, we give it to nitrogen. And this is our final formula, Ca3N2. For number 2, magnesium and oxygen, magnesium is +2, oxygen is -2. We trade those numbers, Mg2O2, and you can reduce this to MgO. You don't have to leave the 2's there. You can reduce them because they're the same number. So just like in math, when you can reduce something down, it's the same idea. And number 3, calcium and chlorine. Calcium was +2. Chlorine was -1. We trade those numbers and we end up with CaCl2. Notice that when you write the number, it becomes a subscript, so it needs to be a little lower. Also notice that you always write the positive ion first. And if you're going, well, how do I know which is the positive ion? It's the one that has a positive oxidation number. The other way to know is that you read across the periodic table from left to right, just like you read in a book. So calcium comes first on the periodic table on your left, and nitrogen comes on your right. So you're reading from left to right, calcium and nitrogen. And that's the order you put them in when you make the compound. Now, you might be wondering, well, how does this work? Why does it work? What's going on that allows it to work? So, let me show you when we draw it out. We will back up to this one. And we'll show you what it looks like when we actually draw these out. So, calcium has 2 outer electrons. Nitrogen has 5 outer electrons. You will need to be able to do the dot diagram, so you may want to practice this a few times. We will do some in class as well that you can practice. So calcium will give up. It doesn't want these 2 electrons anymore, so it will give them up to nitrogen. But the key here is that calcium doesn't have enough electrons to give to nitrogen to make nitrogen happy. Nitrogen still has this one empty spot right here. So calcium needs to bring along a buddy and help fill that nitrogen gap. Well, the problem here is that now calcium is a little unhappy. He needs somewhere to send that electron. So we bring along another nitrogen. Calcium passes along that electron. Oh, well, unfortunately, nitrogen is still not happy. So our calciums need to bring another buddy. And now they're all happy. They all have outer energy levels that are full. Calcium's given away all its electrons. Nitrogens have filled all the spots. And if you notice here, we have Ca3, and here we have N2. And there's our formula, Ca3N2. So you should definitely practice those. Maybe pause the video here and practice some of those other ones, the drawing, and make sure you've got it.